Okay, so in this video now we'll be seeing some important formulas that will be required for solving the numericals from this chapter. Okay, so we have to find out two important things here. First is the direct stress and bending stress. Direct stress we know P divided by area, force divided by area. So area formulas we everyone know. For rectangular section A area is equal to B into D. For circular section area is equal to pi d square by 4. So these are the two areas. In case of bending stress, the formula is m divided by z. This m is couple equivalent moment, that is force into distance between the two forces or eccentricity, and this z, this we have to study now properly. So for calculating this z, we have to understand what is z and then what is I also, that is moment of inertia. So the first point that we will be starting is z, that is called as section modulus. Is section modulus. Now what is section modulus? It is defined as moment of inertia per unit distance of extreme layer from neutral axis. So it is denoted by z. We just have to remember this formula. This z is equal to I divided by y max. Very important formula, where what is the I stands for? I stands for moment of inertia. Now this moment of inertia, we should know all the formulas for this. Now we'll write here separately the moment of inertia formulas of some standard section. It is denoted by I. Okay, so moment of inertia, it is denoted by I. So we'll take one by one section. So the first section that I am taking is a rectangular section. So for this rectangular section, there are two axes. One axis, it is passing through x, or we can say it is in x direction, and the another axis is in y direction. This point is centroid. Now the moment of inertia about x-axis, that is Ix, this is equal to, we will give the dimensions here. This dimension is b, this dimension is d. So the formula for this is bd cube by 12, bd cube by 12. So this is Ix. Similarly Iy is db cube by 12, opposite. So this is for rectangular. For square, it will be b is equal to d. Okay, so you substitute it there, you will get the exact equation. Now the second one that we'll study is circle. So for circle, we have seen the centroid lies at the center point, then this is the x-axis and this is y-axis. Now here Ix and Iy both are same, and the value of moment of inertia for circle is pi d power 4 by 64, pi d power 4 by 64, where d is the diameter of circle, d is the diameter of the circle, pi d power 4 by 64. Now if we apply the definition of section modulus, so here there will be two section modulus, one will be in x direction and one will be in y direction. So for the section modulus in x direction, that is zx, so this will be equal to Ix divided by Ix divided by y, or we can say y max. But what is the value of Ix here? Bd cube by 12, and the value of y max is d by 2. It will be d by 2. So this is b d square by 6. Similarly, zy will be db square by 6. So remember these two formulas also, zx and zy. For circular section, both zx and zy will be same, and this will be same formula, I by y max. In this case, y max will be d by 2, pi d power 4 by 64 divided by d by 2. So this is pi d cube by 32. Now these are the two formulas for circular and rectangular section. Now we will quickly see the formulas for hollow rectangle and hollow circular section. Okay, now this is a hollow rectangular section. For this, the dimensions will be like this. The inner dimension is b, small b, outer dimension is capital B. Inner dimension is small d, outer dimension is capital D. This is x and this is y. So in this case now, x will be equal to capital BD cube by 12 minus small bd cube by 12. Iy will be equal to capital db cube by 12 minus small db cube by 12. To find out zx and zy, you can use the formula Ix by d by 2 and zy will be Iy by b by 2. So substitute it here and you will get the answer. So we can get some problems from this also. So we are writing directly the formulas here only. The last case is hollow circular section. So same for hollow circular also. The outer dimension is capital D and the inner diameter is small d. Formulas will be same. Ix and Iy both will be same in this case for circular section, and formula will be pi d power 4 by 64 minus small pi d power 4 by 64. Now why we are doing this subtraction? Because if you look it properly, then this is a combination of two rectangles, okay, and we are finding the moment of inertia then in x direction. Then what we are doing, we are finding the outer moment of inertia and subtracting it from the inner moment of inertia. So hence we will be getting this moment of inertia of hollow circular or hollow rectangular section. Similarly in this case also, for circular we know the formula is pi d power 4 by 64. So if we do the outer circle minus inner circle, we will get this formula. Similarly, the value of zx and zy will be same, and this will be Ix by capital D by 2 or Iy by capital D by 2. So these are all the formulas that will be required. Now only thing that we have to see, when to use zx and when to use the zy. So this we will see in the next class.